This is for the method of undetermined coefficients, and this is the simplest cases that you can have for the method of undetermined coefficients. There are some more complicated guesses, and sometimes you have to modify the guess. We'll get to that later in the playlist. So it's applicable to second order, constant coefficients, little a, little b, little c are constant, linear, ordinary differential equation. It's not homogeneous, it equals some g of x, and essentially we can guess what the particular solution needs to be in order to satisfy g of x in a limited number of cases. So let's start with this one here. So if g of x is a polynomial, in this case a third degree polynomial, a good guess for y particular of x is some unknown third degree polynomial. So capital A x cubed plus capital B x squared plus capital C x plus d. The reason this has an intuitive chance of working is y particular prime of x. If I take the derivative, it's going to be 3 times capital A x squared plus 2 times capital B x plus c, capital C. If I take y particular double prime of x, well, that's going to be 6 capital A x plus 2 times capital B. And now if I take this y particular and its derivative and its second derivative and I put it into the differential equation, so it would be little a times y particular double prime plus little b times y particular prime plus little c times y particular, and I want that to equal 2x cubed minus 1. Well, I have a constant here, little a, times a first degree polynomial, the 6 capital A x plus 2b. I add that to a constant times a second degree polynomial, the y particular prime. Then I add that to another constant, little c, times a third degree polynomial. So what will end up happening is, right, all of these capital A, capital B, capital C, capital D will get jumbled up between all of these. But if we simplify it and add everything together, it's still going to be a third degree polynomial. And so there's a chance that we can pick these capital A, capital B, capital C, capital D, so that this third degree polynomial, which might be a bit of a mess, we get on the left-hand side, we can pick those unknown coefficients to equal this right-hand side, 2x cubed minus 1. And so this method is called the method of undetermined coefficients because that capital A, capital B, capital C, capital D are undetermined, and they're coefficients. A little bit fancier than the method of guessing, but they couldn't put that in the textbook, so it's called method of undetermined coefficients. But that's the idea, and we'll do some examples later on the playlist. But let's go. So this is for a third degree polynomial. If it's nth degree, you have to guess an nth degree polynomial. In this case, we have g of x is 4 times e to the 7x. So in that one, we're going to guess y particular of x is equal to some unknown constant a times e to the 7x. The reason we want to do that is if we take the derivative and then the second derivative, so y particular prime of x, well, that's going to be 7a e to the 7x. If you do y particular double prime of x, that's going to be 49a e to the 7x. And so if we add together a multiple of y particular and a constant multiple times y particular prime and another constant times y particular double prime, it's going to be, some number of a's times a number times e to the 7x, and we have to get that to equal 4 e to the 7x is on the right-hand side. It's plausible we can pick this capital A in order to do that. This guess is a little different, so this is kind of the third case that you can guess for. So here we have 13 times sine of 2x. So the idea is we're going to guess for y particular of x is equal to, we actually have to guess two different sine functions together at the same time. We have to guess a times cosine of 2x plus b times sine of 2x. The reason we have to guess both of them is in the middle term, things flip. We'll see this in the example solution. But y particular prime of x is going to equal, let's see here, 2 pops out from the chain rule, the cosine gets a negative, so we get negative 2a sine of 2x, and then we'll get a plus 2b cosine of 2x. Here we have y particular double prime of x, that's going to be, let's see, negative 4a cosine of 2x. minus 4b, because derivative cosine is a negative sign, and the 2 comes from the chain rule, minus 4b sine of 2x. And really here, if I only picked one half of it, if I pick just cosine or if I pick just sine, I'm going to get this contaminating term in the middle. So we actually need both. And we're really solving for 13 sine 2x plus 0 times cosine of 2x in this example. So it'll be a little more sense to see it in action. But this is the idea. You guess essentially a solution that looks like the right-hand side that you want, has the same form, and then you're going to go through to all the derivatives, add them together, and figure out what your undetermined coefficients are to actually get the left-hand side of the ODE to equal the right-hand side g of x.